Hello again. Today we're going to move on to Unit 2, which is solving equations, linear and quadratic. We're going to start off with solving linear equations. So this is lesson 2.1. And let's get started. There's a series of steps that you usually follow in order to solve a linear equation. If there are parentheses, you're going to expand them using the distributive property. You will need to remove fractions by multiplying every single term by the lowest common denominator once you figure out what that is. You'll use addition and subtraction to move all of your x's to one side and what I call all of your non-x's to the other side. And then lastly, you're going to divide to solve for x. So let's do a couple of examples. Let's talk about this one. It's really heavy with fractions and it's got parentheses in it, so I think we'll be needing all of our steps. So first of all, if I distribute that 1/3 on the left to each term in the parentheses, I will get 1/6 x plus 4/3. And then if I distribute that 1/2 to every term in the parentheses on the right, I will get 3/8 x plus 1/2. Alright, I look at my denominators and I notice there's a 6 and a 3 and an 8 and a 2. Well, the lowest common denominator of all of those is 24. So if I multiply every single term by 24, I should be able to get rid of any fractions that are in my equation. So I multiply every single term there by 24. 24 times 1/6 x is going to give me 4x. 24 times 4/3 is going to give me 32. 24 times 3/8 x is going to give me 9x, and 24 times 1/2 is going to give me 12. So now I've got some x's on the left and some x's on the right. So typically what I do is I move the x's to the side where the x coefficient is bigger. So I'm going to move my x's to the right because the 9 is bigger on the right than the 4 on the left. So I'm going to subtract 4 x's from each side. That will get rid of the x's on the left, which means any non-x's need to go to the left. So I will subtract the 12 from the right, and I will subtract 12 from the left as well. That means all of my x's should be on the right, which they are. There's 5 x's, and all of my non-x's, 20, should be on the left. So they're separated, so I only have to do one more thing, and that's to divide by 5, and that gives me x equals 4. And as always, I would go back and I would check to make sure that that answer is correct by plugging it in. I won't go through that process with you. We may go over it in class tomorrow if there's any questions or problems with that. Now there are some common expansions before I move on. We've talked about the distributive property where if you have a number a outside of a bunch of things being added together or subtracted in parentheses, then you multiply every single term that's being added or subtracted by a, that number that's being multiplied outside the parentheses. Okay, and then if you have two sets of parentheses, this is commonly referred to as FOIL, where everything in the first set of parentheses needs to be multiplied by everything in the second set of parentheses. So a needs to be multiplied by c, a also needs to be multiplied by d, and then b needs to be multiplied by c, and b also needs to be multiplied by d. Notice that a and b don't get multiplied together because they're in the same set of parentheses, and similarly c and d don't get multiplied together because they are in the same set of parentheses. Okay, and if I square a plus b, that's the same thing as in the line above, changing every c to an a and every d to a b, and then it would look exactly like a plus b times a plus b, or a plus b squared. That ends up being a squared plus 2ab plus b squared. Okay, and if I did a minus b all squared, then the only thing that would change is that middle term would become negative. It would be a negative 2ab. But the a squared would stay a squared and the b squared would stay b squared. Now if I did one of each, if I had a plus b times a minus b, that gives me a squared minus b squared, because if you actually do FOIL it out, you get a plus ab and a minus ab, and those two cancel each other out. So there are no ab terms in your answer when you are multiplying a plus b times a minus b. That's actually referred to as a difference of squares based on the answer where you've got two perfect squares being subtracted. difference of squares. All right, so here's a second example that we're going to go through. X plus 1 squared equals x times x plus 4. So using the rule that I just talked about with x plus 1 squared, I'm going to square the x, and that's going to give me x squared. I'm going to multiply the x and the 1 and double it. That's going to give me 2x. And then I'm going to square the 1, and that's going to give me 1. So on the left-hand side, I have x squared plus 2x plus 1. On the right side, it is distributive property, so the x gets multiplied by the x inside the parentheses, giving me x squared, and the x gets multiplied by the 4 inside the parentheses, which gives me 4x. Alright, so there's my equation so far. I've got x squareds on both sides, but I've got the exact same number, so those will subtract out. And I will just have 2x plus 1 equals 4x. Okay, again, my 4x on the right is bigger than the 2x on the left, so I will put my x's on the right where the bigger coefficient is. That means I'm going to subtract 2x's from each side. That's going to leave the 1 on the left, and it's going to leave me with only 2 x's on the right. And then if I divide, 1 divided by 2 is 1/2, and 2x divided by 2 is just x, so my x equals 1/2. So that would be the solution to this equation. Again, I would check it just to make sure. And that's how you solve linear equations. If you have any questions about the expansions or solving linear equations, please let me know. And I will see you tomorrow.